This video focuses on DataBricks, which is Microsoft's cloud-based data management and transformation solution. Note that DataBricks is an independent provider that was adopted by both Microsoft and Amazon, and so the integration supports both. Our focus is Microsoft Azure DataBricks. The data was uploaded to Blob. It needs to undergo various transformation processes before being analyzed for inventory purposes. Azure DataBricks is a data management service that brings data lakes, massive and largely unstructured data volumes, to lakehouses, systems essentially built to house and exploit these volumes. DataBricks is popular in certain circles like data science, data engineering, and machine learning. In DataBricks, processes called jobs perform various tasks like data transformation and analytics. These jobs rely on various technologies like SQL and Python code, jar files, standalone tools called notebooks, and wheel tasks, and a lot more. Automic can trigger these jobs. DataBricks has its own internal job processing tool, and so from our perspective, DataBricks jobs are black box. Automic only needs an Azure Job ID, which we reference in our jobs objects. Installing and starting the agent produces a file system with the usual lib directory and files. It also creates a template con object. For each DataBricks instance, you'll need to create a con object. The agent also creates two job templates. The first is a conventional job, in which you simply reference the Azure Job ID or JSON. We'll get to this later. The second is a cluster job. A DataBricks cluster is a temporary virtual environment inside of which developers run their DataBricks code. They will create the cluster using proprietary Azure tools and then start the cluster, which contains the necessary computing resources for more complex data operations. This means that clusters are optional. Simple DataBricks jobs probably won't require one, but complex jobs may. There are two types of clusters: interactive, which has no impact on Automic automation, and job clusters for job batching. Like DataBricks jobs, DataBricks clusters have unique IDs. In order to automate those cluster-based jobs, you need two Automic jobs, one to start and stop the cluster, and one to execute the job inside of it. Note that DataBricks technology is owned by the DataBricks company, who over the years established integration partnerships with Microsoft Azure and AWS. This impacts the Automic job templates. Submission is the same, however, authentication varies. Let's consider the con object. As we've already mentioned, we can execute DataBricks jobs for both Azure and AWS, and so we'll select the appropriate platform. The underlying technology is the same, but not authentication. We need to specify the workspace URL. When you set up your DataBricks account, a unique workspace is created for your organization. Use the endpoint URL to access the workspace interactively. You also have to reference it in the con object. Authentication varies with the provider. We'll consider the various methods available to each. In its simplest expression, the Automic DataBricks job is set to run now, has a con object, a DataBricks job ID, and no additional parameters. You click the Browse function and select the ID. Automic will connect to the workspace based on the endpoint URL set in the con. The Automic job triggers the matching DataBricks job, provides monitoring capabilities in both Automic and DataBricks, and retrieves the status, again in both environments. The Run Now type acts as a simple trigger. The entirety of the process is owned and managed by DataBricks' native workflow management tool. Automic's role is limited to trigger and status capture. The other type is Run Submit. This option bypasses the DataBricks workflow tool. The job is submitted directly via JSON payload without a job ID. The job cannot be tracked, monitored, or reported on in DataBricks. Automic Automation owns the process from start to finish. You can also pass parameters via JSON to the Run Now with Job ID job. In this case, you simply add the parameters you need in your syntax, and then define those values using your preferred methods. You could, for example, define var objects with or without a prompt. At runtime, those values can be updated on the fly and passed dynamically to your DataBricks job. Finally, we've already touched on the start and stop cluster job. If you're relying on a cluster to run your data processes, then you can select start or stop and enter the cluster ID as it's known in DataBricks. You can then synchronize this job with your run jobs.